Hello, everybody. In this talk, I want to give you pretty much, a tour of JSON schema and how it is used beyond, just simple validation, as the title says, and how, it's very interesting when you get to use JSON schema as a source of truth of everything you do. For example, in a data or tech company, I think that can unlock, some very interesting use cases. Again, the intention is not to actually go really deep. I think, many of the things I'm going to show you could be talks on their own, but it's more of a higher level overview of how, it fits together and what the ecosystem looks like and overall, what's possible. So you can at least get some inspiration for, or hopefully get some inspiration for the kind of stuff that you are working on. But first of all, why me and why you should even, take some of your valuable time actually, to bother listening to me. I'm a member of the JSON Schema Technical Steering Committee, so I work a lot, in the open source organization as well. I did award-winning research at the University of Oxford around JSON Schema, and I'm going to talk a bit more about this, later in the talk. But I've been looking a lot into how can you do a space-efficient data transfer using JSON Schema, mainly from an IoT use case. So just for some context, I used to work at an IoT company before having my own company and being involved in JSON Schema. I also wrote, by the way, an O'Reilly book. Is the one that you see here. I think I heard that some of you already might have read the book, so that's nice. It came out last year, and it touches mainly on JSON schema from a data science point of view, even though a lot of it is applicable, to use cases beyond data. So that was a fun thing, to work on last year for sure. And finally, now I have my own company. The company is called Sourcemeta. You can find the link at the bottom left in the slides. But we're pretty much a company around JSON schema, right? It came from a lot of the pain and opportunities that I was seeing at the ecosystem and being part of the ecosystem myself, and trying to unleash that power that JSON schema has and providing enterprise high commercial, both commercial solutions around JSON schema, but also training, for example, and more hands-on consultancy. So I'll touch more about what the stuff that we do also later in the talk, just for reference. But anyway, first of all, if we get back to the basics, what is JSON schema? And I presume that a lot of you already know JSON schema, so this might be a bit boring, but just to give you a very high-level overview in case you're not very familiar, it is a very successful and very widespread open source standard for describing the structure and meaning of JSON data. And that's a screenshot, by the way, on the website. That's the official project website, json-schema.org, if you want to go there and learn more, about what we do. And if you just want, a refresher of how a JSON schema looks like, that funny JSON syntax that you see at the bottom right of my slides, that's a JSON schema that describes a person instance, for example, and I took this from the official website, from the docs. Just to see, in case you haven't never seen a JSON schema before. But here's the thing, and why am I even giving this talk? JSON schema is everywhere, right? So chances are that you have already at least heard about JSON schema, and you're probably using it or have used it or know anybody that or somebody that has used it in the past. And that's because of a variety of reasons. One of them, of course, is because JSON itself is the world's most widely used data format. So everywhere you look, JSON, both in APIs, data science, even IoT, right? JSON is pretty universal. It has some pros and cons, of course. Space efficiency is one of the things that people criticize the most about JSON, and I'm going to touch on that as well because I think that can be solved. But overall, I think you probably agree that JSON, for better or worse, it won as a data format out there. And as a consequence, also JSON's popularity, JSON schema over the years it became pretty much the industry standard universal language for data, I like to call it. So you use JSON schema for describing anything that has to do with JSON, and again, turns out that JSON is everywhere, so therefore, right, JSON schema grew a lot. And the beauty of it, you might be thinking, okay, why JSON schema is the best schema language even for JSON compared to many other ones, right? I think there are many lesser known schema languages for JSON, and even some other, highly successful schema languages that maybe have some JSON compatibility, like protocol buffers. And actually, I believe that the answer is very legit here. It's not accidental. So JSON schema, if you dig more into the ecosystem, and again, I'm going to show you some stuff, but again, it is not like it's supposed to be an in-depth thing. JSON schema, it is extremely expressive, right? So the kind of stuff that you can describe with JSON schema compared to other schema languages is way, way more by orders of magnitude, right? If you, for example, have familiarity with protocol buffers, you usually can say, okay, this field is a string, right? And maybe, I don't know, it has as minimum this number of letters. But then with JSON schema, you can say, okay, this is a string that represents an email and has at least between this character and this character, or this character and this character, and it starts with a letter, K, and it contains an @ sign somewhere in between, right? That level of granularity is something that I believe has made JSON schema extremely powerful. And you cannot usually find this a lot with many other schema languages. And again, just as a consequence of all of the things that I've said, we have seen increasingly wide adoption across industries. Again, APIs is a major use case of JSON schema, as you probably know. The financial space is huge on JSON schema as well. Data science, which was the topic of my O'Reilly book, is also a big one. Databases, even, and I'm going to touch more on that, soon, and a lot more other industries. And pretty much all of the big names out there, they use JSON schema, right? And some of them, for example, I believe Microsoft and Amazon and Oracle, not only they use JSON schema, but they ship products that directly offer JSON schema functionality to their users. So it's, the second level. So from big companies like Microsoft, the governments themselves, JSON schema is everywhere. And if you are, for example, open source fans, I think you might find it funny to hear that actually the Linux kernel itself, they use JSON schema as well as part of their device tree mechanism. So you can actually find some schemas, in there on the actual kernel source code, which is kind of funny. And on the API space, just as more data, I guess, on all of these, Postman publishes this report where they consistently identify JSON schema as a key specification in the space. So according to these, state of APIs reports that they publish, they found that 94% of the respondents would either use or know about JSON schema. So, pretty big by far. As you can see in the title over there, it says JSON schema holds the lead, which I think is very neat. And actually the numbers, 94 is already pretty good, right? But I think the numbers are even higher when you consider that many of the other specifications they are listing here, they're actually built on top of JSON schema. So for example, OpenAPI or Async API, which we're going to discuss a bit more, during the talk, they are very popular specifications in the API space, and they actually use JSON schema. They are defined with JSON schema, and they embrace JSON schema for a lot of stuff. So in theory, the numbers are much higher, right? I would dare to say that maybe in half of the technologies in this list, they're all, JSON schema, which is very nice. And I think, came to explode so much that nowadays it's very rare to encounter, API, data, AI, or even IoT companies that don't use JSON schema in some way or another. So I think, it has been very fun times for sure. And as a consequence of all of these, I think the JSON schema ecosystem is as vibrant as it has ever been. And by the way, for some context, JSON schema is not new technology, right? I don't have the number from the top of my head, but I would dare to say it's maybe like 20 years old. So it has definitely been around for quite some time, definitely before I even started my tech career, which is also funny, right? And just to expand on something that I said before, because it's something that a lot of people miss, is that a lot of people use JSON schema without realizing that they use JSON schema. And the reason is that because there are many higher level open source specifications that build on top of JSON schema, and sometimes you're not even aware of it, right? So the prime example is OpenAPI. OpenAPI is hugely popular API specification that it's also everywhere. And with OpenAPI, requests, responses, headers, query parameters, and more, they're all defined using JSON schema. So when you're using, OpenAPI, you are using JSON schema, even though a lot of people don't realize it. They often think that some of the syntax to define JSON documents within OpenAPI is just OpenAPI, funny syntax in there. But it's actually not, it's a standard JSON schema within OpenAPI. The same, for example, with async API, which I'm gonna discuss a bit more as well. So async API, it's like, think about it as a variant of OpenAPI for event-driven systems. And they also use JSON schema. Then you have the RAML specification that was popular, a lot more popular earlier on. I think even at this point it's considered obsolete or something like that, or not maintained anymore. But it was another API specification based on JSON schema as well. And even on the IoT side, for example, you might be aware of the W3C Web of Things specification to define, things and interaction between things. And they're also heavy adopters of JSON schema. And another one that it's, maybe perhaps less popular in the space, but still is the SDF format, right? Semantic definition format. Also, a bit popular within some IoT niche. And they are also using JSON schema. So you can kind of see the trend, right? The point, here is a lot of times you might not even realize that you're using JSON schema when you are actually doing so indirectly through other specifications. So it's something, to keep in mind, and what actually makes JSON schema as widely used as it is today. And of course, nowadays we live in this era where AI is the big hype, right? So, a description of JSON schema wouldn't be complete if we wouldn't talk about AI. And actually, it turns out that AI is no exception. On, for example, LLMs like, ChatGPT by OpenAI, they actually officially support JSON schema as a first-class citizen in the LLM. And not only that, it's the only schema language that they officially support, which kind of gives you a sense of the popularity of all of these. And the way that they use it, in case you haven't came across that, is that they introduce this feature called structure outputs. And what it means is that you can talk to, for example, ChatGPT, but guarantee that the responses that they give you match a JSON schema. So essentially, you talk with the LLM using a well-defined JSON protocol, and that's huge for a lot of companies that don't want the looseness of just unstructured text, right? So that's a very popular feature. And as you can see there, it uses JSON schema. So you can kind of, again, you force the LLM to talk JSON schema, which is very neat. But again, you're probably by now convinced, that JSON schema is extremely popular. You probably have already known that. But you might be thinking, why everybody seems so crazy about schema languages, nowadays mainly. What are all of these cool organizations that I just discussed, ranging from Microsoft to Amazon to Oracle to governments to even OpenAI? Why is everybody just jumping to the same ship? And I think the answer is actually very simple, right? Is that if you use schemas, you're gonna find that you can get rid of a lot of silly unnecessary glue code, right? So again, it's just an optimization for maybe not write a lot of code, if you can think about it that way. So for example, a very well-known use case of JSON schema is data validation, right? Maybe you have any system like an API or an IoT device, and any data that it's coming to the system, you validate it against the schema to make sure that it's actually what you expect, right? And with JSON schema, for example, you might have one JSON object defining rather, pretty complex validation rules that would be extremely verbose and ugly to do it with a programming language, right? You're probably writing a lot of if conditionals and so forth, and very long chains of expressions to validate some stuff. So you're not gonna only write a lot of code, but the code that you write is gonna be only in one programming language, right? Whereas with JSON schema, you validate potentially many systems written in many different languages against complex validation rules. So again, one of the things, data integrity, you can get rid of a lot of custom validation code. Governance as well, that's a very huge one, mainly nowadays in this phase where everybody is trying to go API spec first. And the thing is that with JSON schema and things like OpenAPI, you can guarantee, for example, in a large organization, that all of your APIs and system interfaces are actually consistent, right? That they're not a complete mess, with everybody kind of doing their own thing. You can apply this governance layer and unify everybody on this common, data definition. So this is one of the big reasons some of the major companies actually adopt JSON schema internally. They deploy massive governance programs, mainly again at enterprise level kind of thing. Also code generation, right? Because The beauty of schemas is that they are not only user readable, but they are also machine readable because they are in JSON. It's very easy to introspect on what the schema is doing and write a lot of tooling on top of that. So as a consequence, you find a lot of open source and commercial tooling to generate arbitrary cool things out of a schema. So for example, you can generate API documentation, you can generate tests, and some of the other things that we're going to be exploring a lot more, during the talk. And some of the fundamental things that I believe, and this is something I was writing a lot in the book that I published last year, is I really believe that every problem is actually a data problem, right? No matter what, any problem that you can think of, both in tech and outside, you can usually reframe it as a data problem. You usually don't have enough data to act on to actually solve it, or your data is a mess, or you need to do something with data so that the problem becomes a smaller problem. So I really believe on this. I'm not sure if you do, but I think it's a very nice quote. And if you take that as a given, right? If you accept that every problem is a data problem, then if your data makes sense, then everything else, flows pretty smoothly as a consequence, right? And not only that, but your life as a developer or as a data scientist, if your data actually makes sense, it's actually fun again, right? I would say, you're not wasting time, fighting the system so much. But anyway, so let's expand a bit more on this, this quote. Every problem is a data problem. How yet many organizations that I talk to, they don't have any same data architecture in place, right? So I think everybody agrees that data is a big thing, and I know, even in business, I think you can even argue that many of the big tech companies that in this era, they have become so big because of data, right? Yet it is very surprising that a lot of people don't, or a lot of companies don't think data first. They're kind of trying to duct tape their way through. And these, I think, surfaces in certain ways, right? I think there are certain symptoms that you can see when a company is not data first. First of all, there is usually no single reusable source of truth of the data definition that the company deals with, right? So that means, for example, I don't know, say that you're a bank, again, like silly example, but let's say that you're a bank. You probably bet that you have some very standard definition of what currency means, or what a loan means, or what a mortgage means, right? Or many of the specific terms in the space, so that all of your systems actually talk about the same thing. Otherwise, you would probably be in trouble, right? Many of your systems, they would do slightly different interpretations of what the same things mean, and you end up with a kind of a messy situation. um and this actually happens a lot, right? When my co-author and we were writing the book, we researched and did interviews with many big companies, enterprises, and this was a major problem, right? This was a real problem. These companies would often, or sometimes, they would burn a lot of money, and a lot of money and time and effort would go to waste, because usually there was some subtle misalignment between two teams on what something meant, and they had completely different interpretations, and it made no sense, and they had to reboot like multi-year efforts after wasting millions. So it's a pretty funny thing. Again, it's like so simple, right? But yet it's so common and so problematic. um Anyway, as a consequence of the above, right, you have no single source of truth of what your data definitions mean. So every team ends up reinventing the wheel, often in its own, weird way. And this is even more acute on companies that have, for example, offices in many different, cities or many different parts of the world, and they have like thousands of APIs that they are creating at the same time, and systems, and they have vendors and so forth, and it all, kind of becomes incredibly inconsistent. Then as a consequence, again, any data API or device integration becomes a complete hell, right? It's impossible to make sense of anything, and you're wasting a lot of time kind of trying, to stick things together. And overall, everything is an inconsistent mess, right? Again, your data layer is a mess. Everything builds on top of the layer. If your data is a mess, everything else is kind of incredibly messy. Um, this one also depends, a bit on the industry, but if you're on any industry that requires any sort of compliance, I think this is a slap on the face. Usually, I think it gets extremely weird, and hard to adhere to any compliance from your industry if your entire data definitions and data story is a complete mess. And last but not least, When in this kind of company, if you are a developer or a data scientist, you're gonna find that I would say, I would dare even to say like maybe 80% of your time you spend writing completely silly glue code, right, without actually any innovation or no any fun in your actual work, right? So again, what you're doing, you're compensating for all of this, but there has to be a better way, right? And that's where JSON schema comes in. And that's really the reason that a lot of these companies really embrace, schema languages in general, but also JSON schema primarily, given some of the benefits that I talked about before. And the idea, if you embrace JSON schema as the core of your data strategy, the idea is that you have all of your business data definitions encoded in one language. And again, because JSON schema is so widespread across APIs, IoT, databases or whatever, you can manage to actually have one language to rule them all, which is extremely powerful. And just to picture how this looks like in some of the bigger companies, for example, that I've seen that use JSON schema, in a very sophisticated way. Imagine that you have a collection of inter-reference schemas that define every piece of data, that you deal with in your company, right? So everything that is, in your business domain, imagine that you have a schema for that, and it's all very clearly and well defined, right? And big players do this. I'm going to show you an example from NASA, because actually NASA publishes a lot of their schemas open source, right? A lot of other companies do this, but by definition, because it's a lot of the internal business definitions of them, they usually it's all closed source, so you don't get to see a lot of it. But NASA is a nice counterexample. For example, NASA has lots of schemas defining everything that they deal with. So for example, what is a duration? They have a schema for that. What a daytime is for NASA, they define that with a schema. What is a hardness ratio? Whatever that means in the context, they define that with a schema. What does a luminosity distance mean? They define that with a JSON schema. And they have it something like this, right? Again, this is open source. You can go look at that. I'm providing the link in there. But they have this collection of folders and directories with schemas for almost everything that they deal with. And you can see, some of the titles and descriptions that they have. So again, a lot of the specific data, data definitions that they deal with, they have individual schemas for all of these, right? And what's the beauty of it? The schemas become the configuration files for everything else, right? All of the systems that you write, or all of the services, or all of the APIs or the IoT devices that you connect to those, everybody kind of reuses the exact same schemas. So they end up all talking the same language. And therefore, all of this data integration mess, it's avoided from the get-go. And when I discuss JSON schema at scale as a foundation for a data strategy, a lot of people tell me, well, but isn't JSON schema just a validation language? And I think a lot of people see JSON schema that way because it's a extremely popular use case. And again, while data validation is indeed a very common way in which people use JSON schema, it actually has never been the only use case. There is a lot more beyond just validations, as I kind of hinted on the title of the talk. So if you open the JSON schema specification, again, this is open source, you can find it in jsonschema.org, and you open up the spec, and you read even the first paragraph, the abstract. It has this sentence over here, and just to put it in there, and I'm quoting, it says, JSON schema asserts what a JSON document must look like, and this is, the validation part of it. But it also says, and this is the red part, it has ways to extract information from a JSON document and how to interact with it, right? And that's like the second half of the JSON schema ecosystem that a lot of people that just see JSON schema at the beginning, they miss. Yet I think this is where the real power, lies. This is where it goes from just a validation language to a foundation for building an entire data architecture. And this is what some of the major players adopting JSON schema at large see, right? And embrace. So just to give you a sense of how this looks like, let me show you some of the fun ways that people use JSON schema today. Again, some of the common ones, and I try to choose the ones that have implementations that are open source or at least available to end users so that you can give them a shot. There are a lot more niche ones, and you would be surprised at the amount of custom JSON schema things that companies do internally at their own companies. But again, this at least gives you an overview. But once more, the intention is not to give you extreme details about how everything works. This is just a brief overview of what's possible and how people leverage JSON schema today. And I'm gonna have links for everything so you can dig deeper, or you can ask me later on as well if you want. Um, One of them is actually using databases. Um, and I think a lot of people don't realize that there are databases that offer JSON schema support as a first-class citizen. And you might be thinking, why does this even make sense? And it comes to the fact on why would you want to have a single unified schema language? So for example, say that you are an API company, you're developing an API and you're using OpenAPI and JSON on your API, right? As most APIs do. So you might define in your API using JSON schema, but then you have to interface with databases in SQL, right? Or something else. And now you have a mismatch between schema languages. And then you have to find ways to convert, between them so that you can reuse the same definitions or maybe generate one out of the other one or manually keep them in sync or some crazy thing like that, right? So that has driven a tendency of databases actually supporting JSON schema so that you can use JSON schema completely, vertical across your stack. And the major database that I've seen, again, it's not the only one, but it's the one that I like the most in terms of the sophistication that they have took into their work, is the Oracle Enterprise Database. Again, I bet that you have heard about Oracle. Huge, very, very popular database. Less so in the open source world, but huge on the enterprise space and on high compliance industries. Um, and Oracle actually is one of the major adopters of JSON schema. And they do a really, really good job. And they have even partnered with the JSON schema open source organization on some of the custom vocabularies that they support and so forth. And they support defining tables using JSON schema as an alternative to SQL, which I think is really neat. You can query database tables using JSON schema. So you can use JSON schema as the query language for real. And you can even, if you have existing tables and they have written using SQL, you can even convert the SQL definitions of your tables to JSON schema. And that's very neat, right? And again, it's not the only database. There are, for example, MongoDB also has some degree of official JSON schema support on the database. And most of the other popular database like Postgres or MySQL, they often have, at least extensions and good extensions, by the way, that add JSON schema capability to the databases in the same ways. But for example, some of the things that people do, say that you're using Oracle, right? And you have your common data definition, registry with all of the entities that your business cares about, and then you go out and define your database tables by referencing those ones. So you reuse the exact same definitions, and then you use those in your API as well, and maybe your Node.js applications would actually again reference the same common data definitions and put them to query the database. So again, so you're like tying together the exact same definitions over and over again. And if you want to learn more about these, mainly for example with Oracle, I have a link. The link that I have at the top on this slide. It's an official case study that we wrote with Oracle in the JSON Schema blog, and it's also a full-blown tutorial, kind of getting started on this. So at least if you want to see how this looks like, in practice or play around with it, do check that blog post. I think you're gonna have a lot of fun with it. And also, by the way, I think something that people don't realize that Oracle, it's a potentially very expensive enterprise databases, but they have offerings that are actually free for developers, and open source and that kind of stuff. So you can actually play around with all of these for free, at least from an educational point of view. Yeah, so this is the link to the blog post if you want to go learn more. Moving on, again, OpenAPI specs is a major use case. However, what you usually see, when you go to the average OpenAPI user, they're going to have an OpenAPI spec, an OpenAPI.yaml file, and they're going to start writing, their endpoints in there. And in the same YAML file, they're going to start expanding, on the schemas and providing some basic definitions. And that's kind of, like the level zero of open API adoption as we kind of tend to see it, right? But the beauty, again, just for more context, in case you haven't heard about Open API, it's a major specification to describe your APIs in a machine readable format that uses JSON schema. It's extremely popular. It's backed by the Linux Foundation, and you probably have seen it already, right? But here's the beauty of it, what I was talking about before, is that while you can again write a single YAML file with all of your schemas, in there embedded into the Open API, the beauty actually of Open API, and when it actually gets really powerful, is that you can reference the exact same common definitions that you have in your company, right? So remember NASA, the example that I showed, and they had the schemas for distance. So then every potential API that works with the concept of a distance, instead of redefining the same thing over and over again in every open API spec, they can just go reference the official definition of distance, right? So then your open API becomes very concise, and it's just pulling different schemas that you have available as like a Lego, a Lego workflow, which is a lot more fun, right? And also a lot more powerful. You get a lot of consistency and probably very elaborate data definitions out of the box. Um, when you have an open API spec, then you can test your API against the spec. So there are many tools, and we're gonna see some of them to guarantee that your actual API specification adheres to your open API specification. So you know that they match. And also Open API has been, a very powerful thing to deploy API governance, right? So for example, if all of the API definitions in your companies have Open API specifications, you can go link them for common conventions, kind of make them all look the same, and unified, and even you can deploy API gateways for higher, governance, metrics on that. And something that, if you remember before, OpenAPI is an adopter of JSON schema, right? A lot of what you do within OpenAPI is JSON schema. So the vast majority of tooling that you see for OpenAPI, it is in a way JSON schema tooling at the end of the day. So it just makes the ecosystem bigger. And similar to OpenAPI, there is also Async API, which I mentioned before. And that's like think of it as an alternative to OpenAPI, but for event-driven architectures. So you can, again, Async API would let you use JSON schema to define, WebSockets APIs, gRPC, Kafka APIs, and more, with all of the same benefits of JSON schema. And again, you get to use once more the same unified schema language for even more things. Async API also happens to be the most widely used standard to describe event-driven systems nowadays. And again, you use your exact same schemas, potentially again from the same common data definition that you have like NASA, and you now use them for a whole other new thing, like event-driven architectures, right? You multiply the advantage even more. So Async API is also part of the Linux Foundation, by the way, like OpenAPI. So it's nice, and it's an increasing amount of tooling in the event-driven space, that builds on top of Async API. So I think it has clearly become a foundational stone in this event-driven world. And this is, by the way, an Async API example. I think if you just very briefly read, these YAML that I have in here, if you're familiar with OpenAPI, it's kind of the same idea, right? Just that maybe tweaked a bit to describe publish and subscribe kind of architectures, but it's a bit of the same. So let's say that you have OpenAPI and Async API specs. One very popular, again, use case that you probably already aware of is that you can generate pretty and interactive API docs out of your API specs, right? Because again, they are machine readable, and they are machine readable because they use JSON schema and define with JSON and so forth. And one of the ones that I like a lot, and again, there are lots of open source and commercial options for documentation. It has been a very profitable, I guess, business space for sure. But I really like Thenio. So Thenio is one that supports both OpenAPI and Async API as well, and they can generate some really cool API docs. As you can see in the landing site in there, they take inspiration from Stripe, which has always been a gold standard for how to define and document APIs. So it's the premise that with Thenio you can get Stripe-like API docs, right? And what's more, just when you think about when you generate documentation out of an open API spec, a lot of it is actually means generating documentation out of schemas in the OpenAPI spec, right? So it is in a way mostly a JSON schema problem. The OpenAPI wrapper part of it is usually the simple part. So it is really mostly a JSON schema use case. And as a consequence, the better your schemas, the better, the documentation. And if you have high quality schemas that you can share across your services, using a data dictionary like you was mentioned, right? Then all of your docs or most of your docs will be by definition out of the box great, right? So that's also a multiplier, in the level of investment that takes, setting up these registries or data dictionaries in place. And again, take a look at the doc space. Again, there are lots of competitors in the space for every need with different features, with different styles. But yeah, this is a very fun use case. But now getting into more elaborate ones. Um, and if you have an open API spec, for example, or an async API spec, or any sort of a spec, that embraces JSON schema, even the IoT ones, right? Because you are essentially providing a formal definition of the interface of your service in a way that is also machine readable, it unlocks very nicely the idea of contract testing. And contract testing, in case you haven't, seen before, is the idea that you can automatically generate test cases and potentially very complex testing scenarios out of that formal definition, and automatically, fuzz and explore the problem space of the interface automatically, right? So schema thesis, the one that I'm linking here, and I have the link, at the top. It's a very well-known open source tool for actually doing this with Open API and so forth. And it's very nice, actually. It can uncover edge cases and weird bugs in minutes. Because again, it can generate all of the craziest requests and responses and workflows that you can think of that you would never test on the happy path, or you would never think about that somebody would be crazy enough to do it. They would, right? And it's a very powerful, addition to the whole testing stack. It's also backed by research, by the way. So this paper that I'm linking here, this is written or co-authored by the author of Schema Thesis, the same open source, program that I just shared, and it has proven by research to be the most elaborate and sophisticated API fuzzer out there compared to other, fuzzing technologies that they consider in the paper. So really, really cool tech that can take, again, your manual or automated, QA to the next level if you are writing APIs and that kind of stuff. And again, once more, Schema Thesis, the one that I'm showing, is fully open source. So again, there's no reason to not actually look at that and try to embrace it. But again, I think, here's the fun thing. Because Schema Thesis would be generating data and test cases out of your schemas, right? Once more, the better your schemas, the better, the data that it will generate, which means, the better your testing is going to be. So again, we come down, it all comes to the same thing, right? You have a really good data and schema foundation below everything that you build, and it just cascades down. It's like a domino effect in so many things, right? Again, you get better documentation, you get better contract testing, and so forth. It's really, really worth the investment. Um, then going into more, unknown use cases of JSON schema. Um, Actually, as a fun fact, JSON schema is not only about JSON, even though that might be a bit, counterintuitive, right? JSON schema, the specification on JSON schema, if you read it very carefully, it actually allows JSON schema to work with non-JSON data, like potentially even videos, audio, or image, right? And again, you probably have never seen these before, but I've seen some companies actually doing this kind of fun internally. So, for example, imagine that using these JSON schema vocabulary and some extensions of your own, you can validate the size of images in a media data set using JSON schema, right? That is very cool. And I've seen for real these being used in closed source AI companies for training data, right? And validating media that is used actually for training data. So there are people actually embracing this, even though it hasn't reached a lot of open source adoption yet, because it's a bit more niche and complex to pull off. And that means that in theory, anything can be described with JSON schema, extending this idea of JSON schema being a universal language for data even more. right? So you could again use JSON schema to define videos, right? And maybe assert on the format or dimension on these videos, or maybe even audio files and the bitrate of an audio file or whatever, right? You could it truly unlocks potentially a lot of possibilities that I think yet to be exploited by the open source community mainly. Another one, for example, that maybe you have seen is generating web-based forms out of JSON schema. So for example, this is a project called React JSON schema form. It's a kind of popular, implementation. There are many, many out there. But think about it, right? If UIs, user interfaces in general, they are either presenting data or taking data as input, right? That it's like an interface in a general term, which means that UIs are also a data problem, right? Coming back to what I was saying before. And with JSON schema, you can actually automate, taking data as input, which means that, for example, you update your schemas and your UI updates automatically, right? And maybe, again, as we've seen, if you use the same schemas from your data dictionary everywhere, maybe you update your schemas and you are automatically updating your UI and your API and maybe your database definitions and so forth, right? Yeah, they truly can become the configuration file for your systems, including again all the way to the UI. And this is actually really popular. I think you might not be aware that so many of the UIs that you use on a day-to-day basis, mainly if you're dealing with forms, they are a surprising lots of them that I have seen are actually generated out of JSON schema. So it's a very major, widespread use case. I think again it's very convenient. I don't think anybody enjoys writing forms necessarily. So it's a really cool one. LLMs, it's also an interesting one. And again, we have touched on the OpenAI, structured output kind of thing. There is this company. It's a bit of a new company. I really encourage you to look at that. It's called .txt.ai. It's a very well-funded, hot startup at the moment. And what they do is that they take the idea of OpenAI talking JSON schema to the next level, right? So they use JSON. They essentially have trained the LLMs to not only convert the output to JSON schema, but talk JSON schema from from the get go. Like that's really the only language that they talk, right? They have really trained the languages, all the LLMs, with JSON schema from the very core. And the idea again is like, why bother with lossy and messy plain text, this is what happens if your LLMs would truly talk and only talk JSON schema, right? Which means that you can really embrace LLMs to talk your data model, right? They talk your language. You make them talk exactly as you want. This means that you can, mainly with things like .txt, you can reduce ambiguity and hallucinations a lot by always making use, of a formal protocol by talking to them. And again, it's not a conversion between unstructured text to LLM. It's not like you go to Claude or ChatGPT and say, generate me a JSON object, right? Which is gonna reason and try to generate a JSON object that is hopefully valid. Like these kind of LLMs, they will and only will generate valid definitions. That there is no other way from the very core of it, which is very nice. And again, you can finally stop arguing with LLMs to give you the exact information that you need. They will give you the correct one by default, period, right? There is no even option for anything that deviates. And again, even something that I was touching before, AI in general, it's only making foundational data technologies like JSON schema more desirable, right? And I think you can see how much the data space is getting pressure because of AI. And as a consequence, I think AI is also a big factor for why the whole schema story has been growing, like crazy recently. Another one that is very interesting is synthetic data generation. So for example, there are many tooling, again, open source and commercial, that can generate arbitrary random data out of schemas. And this, by the way, schema thesis, the contract testing technology that I have talked about before, they kind of build in the same idea of data generation for these things. But from a data science scenarios, I've seen this idea of generating synthetic data out of your data model being very cool for simulations, digital twins or chaos testing and that kind of stuff. So again, very popular. I've seen it mainly on scientific use cases. People generate lots of really cool stuff with this. And once more, all of these use cases are as good as your schemas, right? If you have, again, a very well curated data model that you have across your company and they are very detailed, the data generation that you're going to get out of it is actually going to be very rich and very precise, which only makes, simulations or digital twins easier to produce. So once more, good schema foundation that cascades all the way to so many interesting use cases, right? So again, this is one major forcing function for having very detailed schemas that I have seen. I think people want to get into the data generation space and they realize that their schemas, well, they are not bad, right? They are not very precise. So then the data generation that you get is a bit, weird. So then they go back and start polishing their schemas a lot more, which then in turn, improves the documentation and improves the testing and so forth, right? Another one is configuring API gateways as a first line of defense. For example, most API gateways, and I'm quoting KrakenD, it's a very well-known API gateway. It's open source and it's one that I personally like a lot, but there are many of them. A lot of API gateways can ingest open API specs or JSON schemas directly and provide input and output validation, right? So if you deploy this as your entry level in your cloud, then you can by definition guarantee that any data that crosses the barrier into your internal cloud maintains a certain degree of data integrity, which once more, if your schema data model is very precise, then suddenly your data integrity is huge everywhere, right? And low integrity data never gets into any of your systems almost by definition. And again, most popular API gateways support this kind of stuff. KrakenD is just one that I happen to like and use a bit. And for this reason, actually, API gateways have become the major driver or tool behind API governance programs at scale. So what a lot of big companies would do is that they would deploy these API gateways everywhere in their cloud, and they would govern every data that gets in and out using a schema validation, right? And therefore, nothing can be ever violated from a data integrity point of view, which is very nice. And I can imagine, even for personal data identification or any, more compliancy related stuff, in theory, for example, you can craft your schemas to detect personal identifiable information and completely get them off of your system using an API gateway, for example, so that can be huge from a compliance point of view, right? Also, again, another one describing IoT things using JSON schema, and I briefly talked about the Web of Things, specification by the W3C. It's not the only one, right? There are more. But again, it brings all of these niceties about the schemas and the reusability of the same data dictionary, but now to the IoT world, which is also very nice. So again, you can, for example, imagine that you have your data model written with JSON schema, and in there you can have common definitions of devices, systems, protocols, data models across vendors, and so forth. All coming back to the exact same schema-driven data architecture, right, that we've seen. These kind of IoT models, I've seen them. They can be very interesting also for simulations and digital twins, right? Because again, you are modeling the real world in a way using JSON schema, right? Which is very nice. And again, overall, you're bringing the benefits of something like OpenAPI to the Internet of Things. And again, because your APIs are also potentially described using JSON and JSON schema, now you are once more using the exact same data format and technology for yet another use case. And again, this is not an exhaustive list. I try to show you some of the most fun ones. There are many other niche use cases. Like, for example, I've seen people using JSON schema to build declarative data pipelines. You can actually define even data transformations with JSON schema, even though it's a bit more of a niche use case. And even down to the level, if you have seen JSON schema, it even allows complex conditionals and that kind of stuff. What people don't know is that the annotation extraction mechanism, which is a whole thing, I'm not going to discuss it in here because that could be its own entire talk. Some people use JSON schema to define basic API logic itself. So then your API spec, it not only describes the API, but actually implements it as well. You can actually implement basic API endpoints using JSON schema alone with a basic, engine behind it. So that's a more of a novel, niche use case that I've seen, kind of emerging slowly recently. There is also the schemas vocabulary for hypermedia on JSON data. I think this can be very powerful. For example, if you have JSON data sets in your, I don't know, data science or whatever, or simulation, use cases, You can use JSON schema to automatically link your data sets with their documentation or related data sets or whatnot. I think that can be a very fun for some more automated data systems, and a lot more, right? And again, I think the takeaway, if any, is that developers are inventing new clever ways of using JSON schema every day. So the list is like never ending. And mostly, in closed source, ecosystem. Again, I think the open source world and the things that you can see available there are just the tip of the iceberg. You wouldn't believe the amount of crazy, sophisticated custom tooling that I've seen some enterprises build internally that works on schemas. But zooming out a bit, right? I think there is a maturity journey when adopting JSON schema, right? Because it's not like you say, okay, let's use JSON schema and suddenly you get all of these benefits on day one, right? I think you get stage zero in a way, right? Where you have little to no schemas at all in your company. And that's data integrity errors at 3 a.m. Keep life interesting kind of mindset. Again, your data is not governed at all. Then you get into stage one, which is some basic validation, right? At least your data is consistent. Now you're not using that for a lot more yet, but at least you are getting there. On the second stage, I think you see that once you have gone through the validation phase, now you are generating fun things out of your schemas, and things are becoming a lot more fun now, right? You're starting to extract the value of a schema-driven architecture. And then, the final one is that the schemas become the source of truth of everything that you do, right? Everything is consistent and everything is configured out of your data model, right? And then you have another one maybe, which is the entire schema-driven architecture, right? Which is that everything that you do is actually defined with the schemas. And that's kind of the holy grail, right? That's when you stop writing, boring code, and everything is kind of automated and all configurable, and you just swap some JSON files and everything kind of works. But again, how do you get there, right? How do you get from this schema voodoo dark magic that some big enterprises are doing to your everyday engineering? And I think that's the core of what I'm doing with my own company, Sourcemeta, right? We're trying to build foundational tooling and resources to make working with schemas at scale, from authoring and management and consumption trivial at scale, so that you can smoothly implement all of those use cases that I just showed you, right? Because again, right now, without a lot of more elaborate tooling that is widely available as open source, companies have to pull off a lot of custom code and custom technologies to actually get this done, right? To pull off an entire schema driven architecture is not very easy, right? You might not even know what the journey looks like or how you should do it or whether you're doing it correctly and what other tooling that you need to actually pull that off. So that's a problem that we're trying to solve. And let me show you a preview of what we're up to, right? So that you can see at least where we're heading. One of the things that it was described in the talk that we wanted to discuss a bit is that Sourcemeta has produced an ultra high performance C++ JSON schema compiler. It is publicly available on GitHub. It's actually, let me see, yeah, so this is the README. It's a incredibly fast JSON schema validator. We, according to the research, and there is a paper that you can read about it on the repo if you haven't already, it is at least 10x faster than other popular alternatives. It can even do a schema validation down to the nanoseconds in some cases, and we are deploying this in very high throughput data systems. Like again, imagine that you have a API ingesting, I don't know, IoT sensor data, and you need to validate sensor data billions per second, right? Without a very high performance, implementation of JSON schema, you might actually spend a lot of compute, money on actually making that work. And not only it is very extremely fast compared to anything else in the industry, but it's also orders of magnitude more memory efficient. And it also happens to be one of the very few implementations of JSON schema that ranks 100% compliance in every supported version of JSON schema. And again, as I said before, a good use case is just validating, for example, billions of sensor measurements per second, right? With potentially commodity hardware. And this is a benchmark, by the way. This is a graph that I have on the paper. You can again read the paper to learn a lot more, but just to give you a brief overview, this is Blaze, right? You can see already just by looking at the chart how fast it is compared to some of the other ones that we are benchmarking. But not only that, actually, one of the things that a lot of readers miss is that if you take a look at the y-axis, which is validation time in here, the y-axis is actually exponential, right? If we would make it linear, like the difference between the bars would be huge. In fact, they were so huge that if we didn't make the y-axis exponential, the chart would be unreadable, right? Like Blaze would barely like show up in there. So we had to, kind of try to make this to make the chart work. And even more on this, before I continue, even on this one, if you take a look at the implementations that we're ranking, they are not all of the ones that we are considering in the paper, because some of them are so slow that even with an exponential y-axis, they would make the chart unreadable, right? So it really gives you a sense of how, crazy fast some of these technologies, are. And you might be thinking, okay, what's the trick? How did you make Blaze so fast, even compared to other C++ and Rust implementations of JSON schema? So it's not only a programming language kind of thing, right? And the trick actually is that we compile JSON schema into a low-level representation. It's like bytecode, if you know Java or any of that kind of stuff, you compile the code into something like bytecode that can be evaluated by a very dumb engine without involving any memory allocation. So that's kind of the main theme behind Blaze is how can you compile these schemas and do memory allocation free dumb evaluation, right, of the bytecode. On top of that, we at Sourcemeta, we also have a custom C++ JSON parser, and it's actually specifically tuned for ultra fast traversals. So again, you can see we have gone down all of the low level of actually even implementing our own JSON parser for a lot of performance tuning that we do at Sourcemeta. And again, lots of coffee and CPU profiling as well. I think that has been another theme on Blaze. It took us a lot of work, actually. This is not easy stuff for sure. But just to give you an example of how this looks like, consider this JSON schema. Very basic. It's an object. It defines properties foo and bar. Foo is a string and bar is a number, right? When you compile it with the Blaze compiler, you're gonna get something like this, right? It's very, very ugly, right? It's a JSON document. It's mostly nested arrays, and it contains numbers and some strings, right? And the numbers are for processing. So essentially, everything that you need to actually work on the schema and evaluate it is brought down to numbers, right? Maybe even analogous to how AI they convert, they vectorize data into numbers for fast processing. We kind of try to do something like that. The entire validation structure comes down to numbers, and we can act on numbers extremely efficiently, right? And the strings that you see here, that they kind of stand out a bit. They're only for error reporting, right? So we have a lot of strings because we need to construct errors, otherwise the errors would make no sense. But essentially, it's that we bring down the schemas to arrays of numbers for evaluation with some, optional strings in there for better error reporting. And this is evaluated with this dumb evaluator that it's extremely fast and involves no memory allocations. Another one that we're working on is JSON binpack. So this is our take on a space-efficient binary encoding for JSON, right? So this one, it's also publicly available on GitHub. And the idea behind it is that you can use JSON schema to derive advanced binary encoding plans based on JSON schema, right? That means that you can compress JSON data using JSON schema. And actually the results are very impressive. When you use something like JSON binpack and you derive custom encoding rules for JSON data, because JSON schema is so expressive, the level of compression that you get, for example, out of telemetry data, is way, way more than things like protocol buffers, right? So if you really want the space efficiency, this is kind of game changing. This was my research, topics at the University of Oxford. I published many papers around this and my dissertation. I actually won a couple of awards for it, so I'm kind of very proud of it. It was a lot of hard work, for sure. And it has some very interesting use cases for space efficient IoT, telemetry over, say, 5G or satellite, when you want to work with JSON, but sending, raw JSON would be extremely expensive, right? And just to show, some of the benchmarks, again, there are papers for JSON binpack as well that you can go check at the GitHub README if you want to explore more. But for example, this is a GeoJSON example JSON file. And this is JSON bin pack. It is the most efficient one space-wise. And this is, for example, something like protocol buffers. So as you can see, it's like over 3 times or 4 times more space efficient than protocol buffers, which is pretty crazy, right? And again, this is kind of how it works. You have a JSON schema and a JSON document that matches that schema, and we derive very custom binary encoding rules out of that, and we turn it into binary, right? So we're looking into deploying this into more IoT use cases, by the way. The other thing that we do, we have a very popular JSON schema CLI, which is like the Swiss Army knife, to work with JSON schema. This again, completely open source. You can find it on GitHub. And the idea of this tool is that it gives you all of the developer experience that you would want when working with JSON schemas. So for example, it comes with a test runner, so you can define unit tests for your JSON schema. So for example, let's say that you're building your data dictionary at your company and you introduce the concept of distance, right? So now you want to write unit tests to make sure that you got your schema right and it doesn't, fail to validate some edge cases or whatever. We have a complete, JSON schema test runner as part of the CLI that many companies use. We have a schema trace debugger and inspector, so if you're having issues with JSON schema or you are confused by some, evaluation or debugging scenario, we can show you, a step through debugging and tracing for everything that is going under the hood so that you can, debug your schemas. And this has been used by, again, like a lot of companies that are working with very advanced schemas, and they find JSON schema confusing, or some cases are extremely hard to debug. This is the equivalent of having, like an LLDV debugger for like C++, right? So you can actually reason about what's going on. So, just more tooling on helping schema debugging in general. We also provide the most advanced JSON schema linter around. And this linter, it has been built in conjunction with the JSON schema org and Google Summer of Code as well. We want to encapsulate all of the best practices and anti-patterns of JSON schema that we have seen at scale on a very advanced linter that if you run your schemas, through these, you will know if you're doing things well or not, right? With lots of suggestions and auto-fixing so that you can really, write really good JSON schemas without, for example, having to hire me as a consultant as I have been hired before, right? It kind of commoditizes all of that. And a lot more, right? We have a schema formatter, schema bundlers, validation logic, and so forth, right? We want to make it the tool for working with JSON schema. And countless of organizations use this. And if you want to learn more, again, I give you a very brief overview of how the CLI works, but do check this talk of mine that I gave at the last JSON schema conference. It has a lot of tips and tricks and showcases the JSON schema CLI a lot more. We also have Learn JSON Schema, by the way. It's the big reference documentation site for JSON Schema, right? It's actually made by us. You can go visit learnjsonschema.com. It has plenty of examples, common pitfalls, and best practices. It's like the site for actually learning about each keyword and how to go and use it, right? It's like the industry standard for JSON Schema documentation. So if you're working with JSON Schema on a daily basis, I think you might like, bookmarking this site, because otherwise, if you try to work with JSON schema by just reading the specification, I think you might have a bit of a hard time, right? The specification is a bit hard to grasp, if any. And finally, we are also building an enterprise-grade self-hosted JSON schema registry to actually power a lot of these more advanced scenarios, right? Like this is how you actually build a data dictionary in your company, right? This is an example of the schema registry. This is a live instance, by the way, that I have publicly available at the schemas.sourcemeta.com. And it ingests various schemas, and you can kind of see how it looks like. But again, you can deploy your company schemas into a searchable catalog, even internally in like a self-hosted scenario. You can reference schemas, from open API specs and editors, back to the registry. You can keep track of the health of your schemas across your org. So for example, this is integrated with the JSON schema linter that I talked about before. So you also can have a higher level view of all of the schemas in your organization and the health in all of them. So you can highlight, warnings and anti-patterns and that kind of stuff, and a lot more. And we're also adding, by the way, advanced schema evolution capabilities to these, so that you can, again, deal with very advanced schema evolution, backwards and forwards compatibility, and schema and data transformation needs that we're seeing, and a lot more, right? This is what we're actively working on as a startup, right? and you can see more about the registry. If you want to give it a shot, go in there. The entire registry is available on GitHub, by the way. So if you want to play with it, host it, or whatever, you can also go into the docs and get started. And a lot of other cool stuff that we have in progress. So for example, we are working on a standard library for JSON schema. So we want to provide hundreds of extremely well-detailed schemas from IETF definitions, i.e. the ISO and many other industry standards, so that you can go and plug and play into your data model from your company without you having to reinvent the wheel, right? It's like, for example, let's say that you want to define email addresses, right? And right now, like every company having its own data model is kind of reinventing the definition of an email address all over again, right? We have a schema that defines email addresses strictly compliant to the IETF RFC of the email address grammar, right? That then everybody can go and reuse, for example. So just making the data model creation a lot easier. We're working on a visual step through debugger for JSON schema. So again, similar to what I've seen shown in the CLI, but more of a visual thing so that you can see what's going on and debug complex scenarios a lot more visually, which is something that we've heard a lot about. And even a JSON schema desktop app for local development. And by the way, for context from us, we are a very small EU and UK startup. We are a bootstrapped startup, and we're funding a lot of the work that we do, like Blaze and the standard library and the registry, with a lot of expert JSON schema consultancy. We do custom development, we do training. We have been working with a lot of major companies in the JSON schema field. And again, being, for example, myself part of the JSON schema technical steering committee, a lot of that work and consultancy comes back to the ecosystem and to the project itself, which is very nice. Anyway, just to wrap up, the talk. What are the next steps that you can take? If you found all of these, very exciting, what can you do to start with this journey? So I think you should start simple, right? Again, if you come back to the JSON schema maturity journey that I shown before, you cannot do all of these in one shot, right? So for example, I suggest pick a small system that you work on. That can be an API or an IoT system or whatever you want, right? But pick just a small one that you know. Create a schemas directory in that project, in the Git repo, for example, and put various, .json files that define what the API is about, right? Just try to extract the business domain of at least just that system in as much detail as you can, right? And you can, for example, use the Sourcemeta JSON schema CLI to work with the schemas, as I've showed you. You can write test cases, you can link them, you can check for their validity or whatever. And you can also use learnjsonschema.com for reference, documentation. And once you have, that schemas directory, try to, at the very least, to start validating every input and output in the system using those schemas, right? Again, all local is just within your project, within a directory there, without any external dependency. Just start simple, right? Have schemas, start creating a very basic data model just for that service, and actually get it to use them for something, right? At least input-output validation before you get into more fun, advanced scenarios. And then once you have that, then try to actually reuse the same schemas with other systems, right? With another second system. I think you will see, once you have your little business domain for your service, once you try to use it in another one, then you're going to find some differences, some things that have to be normalized, some ways to extend the data model, or maybe, you have to rethink how you are creating that data model in the first place. But I think if you continue doing this, right, one by one, simple, right, you're going to start organically creating some sort of data model, right? And once you have that data model, you can start getting into more, fun stuff, right? But again, just start simple. And so this is what I propose, or challenge you, to give it a shot. And if you do have any questions, you get stuck, email me. This is my email address, by the way. I will respond, pinky promise. I'm always available, and I love to help out people. So don't be afraid of just reaching out and asking anything that you want, right? And once you have this in place, right, then you can try out many of the resources and more complex use cases that I linked to in previous slides, right? So for example, once you have some at least semi-advanced data model, you can look into deploying that on a registry, maybe using it in all of your systems, kind of trying to then enforce that from an API governance point of view, starting to define more API specifications and so forth. But again, my suggestion is don't try to do everything at once because it's going to be overwhelming, right? If you don't have something like this already in your company, you have to start small. Start, crafting getting the paving the way for a schema driven architecture, at least one service at a time. And I swear it will work. I've done this on a consultancy basis with a lot of companies, and it can work very well. And also, finally, we have a JSON Schema conference, by the way, every year, in case you're not aware of it. So if you found JSON Schema fun and you wanna get involved a lot more, we do meet in person a lot of the TSC members as well in Paris every year. The next one is happening on December 9th. You can see the page in here. If you do want to come, to Paris to hang out for a day, even potentially present if you wanna present anything, I would love to also meet you, in person, and we can discuss more about JSON Schema and have some fun. So, I can probably get you free tickets, by the way, for the JSON Schema conference. So if you are interested, do let me know, and we can arrange things. And that's pretty much it. So thanks a lot. And let's connect again. I would love to hear from you. I'm very excited about companies embracing this schema driven architecture. So as you potentially start doing something like this, do write to me, and you have my email address. I'm also available on LinkedIn all the time. And again, I work with JSON Schema. It's my full-time job. I'm very happy to call it my full-time job with Sourcemeta. So anything I can do to help, it's my pleasure.